So back in 2018, one of the largest tech companies on the planet had to quietly kill this top secret project.
Right.
They had spent years, I mean, literally years, building an artificial intelligence recruiting tool. And the whole premise was to build this machine that could, scour the globe, scan thousands of resumes in a fraction of a second, and pinpoint the absolute best talent on Earth.
Which sounds great on paper.
Exactly. It sounds amazing. But there was just one massive, undeniable problem. The machine had actually taught itself to systematically downgrade any resume that included the word women's.
Yeah, it's wild.
Right. Like if you were the captain of the women's chess club, or I don't know, if you attended a women's college, the algorithm actively penalized you.
Hmm.
And it wasn't just some glitch in a single line of code, it was the system working exactly as it was designed to.
Which is the scariest part, honestly.
Completely. Because, usually when we talk about a computer program making a calculation, there's this expectation of absolute precision, like a basic calculator. You type in 2 plus 2, the screen shows 4, and you just don't argue with it. It's objective.
Well, it's comforting to think of it that way, right?
Yeah.
We inherently trust the binary nature of a machine. It's supposed to be uh, free from our human messiness.
Right, like our exhaustion or our subconscious preferences.
Exactly. The calculator just doesn't care who is pressing the buttons.
But then you step into the world of artificial intelligence making critical life decisions, like who gets a job, who gets a mortgage, or, who gets sent to jail, and suddenly that calculator is totally broken. Or maybe it was just never a calculator to begin with.
I'd argue it definitely wasn't.
Yeah. So, welcome to the deep dive. Today we are exploring the very seductive yet deeply flawed promise of objective artificial intelligence.
It's a huge topic.
It really is. And our source material today is this remarkably comprehensive article by Dr. Jonathan H. Westover, and it's titled When Algorithms Inherit Bias: Auditing AI Systems for Fairness in High-Stakes Decisions.
And what's fascinating here is that Dr. Westover takes this incredibly abstract, highly technical concept of, algorithmic bias, and he forces us to look at the tangible structural consequences.
Yeah, the real-world impact.
Right, because these systems, they aren't just academic experiments anymore. They are the actual gatekeepers of modern society.
So our mission today is to help you figure out how the very tools that are aggressively marketed to eliminate human bias from these critical decisions often end up encoding it, they amplify it, and then they hide it behind a wall of proprietary math.
And we really need to get into how organizations can actually fix this. The defense playbooks.
Yes, absolutely. But I do want to pause here for a second because Dr. Westover's data touches on some incredibly charged realities, specifically things like race, gender disparities, and the justice system.
Right, which can be sensitive.
Very. So, to be perfectly clear, our goal today isn't to debate the politics of policing or corporate diversity. We are strictly looking at the mathematical reality of these systems as presented in the research. We aren't taking political sides. We are simply impartial observers dissecting the data, the code, and the frameworks that Dr. Westover outlines.
And that is the essential lens for this discussion.
Yeah.
We have to treat AI as a sociotechnical artifact.
A sociotechnical artifact. That's a mouthful.
It is, yeah.
Yeah.
But it's just a term researchers use to describe systems that are inextricably linked to the social environment they operate in. An algorithm is not a vacuum.
Right.
It's a product of human history, human data, and human decisions.
Okay, let's unpack this seductive premise that the article talks about, because vendors have been selling us this utopia for, what, a decade now?
At least, yeah.
The pitch is always the same. Humans are fundamentally flawed decision makers. We get tired after lunch and make worse decisions. We have implicit biases. We play favorites. But machines are pure.
That's the marketing, right?
Exactly. They only look at the data. They evaluate candidates strictly on merit, utterly blind to protected characteristics.
And, if you are a human resources director staring at a mountain of, say, 10,000 applications,
Yeah.
or a bank manager trying to assess risk across thousands of loan portfolios, that narrative is completely irresistible.
Oh, I'd buy it in a heartbeat.
Of course. The idea that you can purchase a software license that not only speeds up your workflow by a factor of 1,000, but also, immunizes you against liability and ensures perfect fairness, it's the holy grail.
It really is.
The entire AI industry's marketing engine has basically been built on this myth of algorithmic neutrality.
But the reality is just a harsh wake-up call. The source provides some incredibly heavy-hitting examples of where this neutrality narrative just completely collapses under scrutiny.
Yeah, the Workday example is a big one.
Yes. Let's talk about the massive 2024 class action lawsuit against Workday. For those who don't know, Workday is a giant in the human capital management software space. I mean, millions of people interact with their software when applying for jobs.
The scale is what makes it so critical here.
Right.
The plaintiffs in this lawsuit are alleging that Workday's screening algorithms systematically discriminated against Black applicants, workers with disabilities, women, and individuals over 40.
So pretty much everyone who isn't a young white guy.
Essentially. And the core allegation isn't that a few rogue recruiters used the software poorly. The allegation is that the underlying architecture of the algorithm itself acts as a discriminatory gatekeeper at a massive scale.
Which brings us back to that Amazon example I mentioned at the very start. I really want to dig into that because it perfectly illustrates the gap between our perception of AI and the reality of how it actually operates.
It's a textbook case.
Because if the Amazon algorithm wasn't programmed by some rogue, sexist engineer who literally typed in rule number 1, reject women, how on earth did it learn to do exactly that?
Well, it really comes down to understanding what machine learning actually is.
Okay, break it down for me.
So these algorithms aren't given a list of explicit rules. They are given a goal, and they are given historical data.
Right.
Amazon's goal was simple. Find us candidates who resemble our most successful past hires.
Makes sense on the surface.
Sure. But to teach the machine what a successful hire looks like, they fed it 10 years of their own historical hiring data.
And the tech industry, and certainly Amazon's engineering departments over that specific 10-year period, was heavily, heavily male-dominated.
Exactly. And the algorithm, it doesn't understand the societal context of why the tech industry is male-dominated.
No, it doesn't watch the news.
Right. It doesn't know about the history of STEM education or, cultural biases. It only knows patterns. So it processes millions of words in that historical data, mapping them into this complex, multidimensional vector space.
Okay.
It looks at the resumes of the people who got hired and promoted, and it just notices statistical correlations. It notices that the word women's, as in women's chess club or women's collegiate sports, rarely appeared on the resumes of the historically successful group, which was, of course, mostly men.
Wow. So because the word literally didn't appear in the quote-unquote success pile, the machine mathematically infers that the word itself is a negative feature.
Precisely.
It's penalizing the word because it just correlates with a lack of historical representation.
Yes. It was optimizing for past patterns. And no matter how hard Amazon's engineers tried to, patch the system to ignore those specific terms, the AI just kept finding new ways to reconstruct the bias.
Wait, really? How?
Well, it started penalizing graduates of 2 specific all-women's colleges.
Oh my gosh.
Yeah. It just found different statistical proxies for the exact same demographic trait. Eventually, they just realized the foundation was fundamentally broken and they had to scrap the whole project.
It's just wild to think about. And then Dr. Westover's text moves from employment into the criminal justice system, which, that raises the stakes astronomically. The article cites the 2016 ProPublica investigation into COMPAS.
Yes, COMPAS. That stands for Correctional Offender Management Profiling for Alternative Sanctions.
Okay.
It is a risk assessment software, and it's used by judges across various jurisdictions to predict recidivism.
Which means?
Basically, the mathematical likelihood that a defendant will commit another crime if they are released.
Okay, so picture this. A judge is sitting there looking at a defendant, and they have this algorithmic score. Let's say it's a number from 1 to 10, telling them how dangerous this person is. That number carries immense weight.
Huge weight.
But ProPublica looked under the hood of those scores, and what they found was just staggering.
They analyzed the risk scores of thousands of defendants and then tracked them over 2 years to see who actually reoffended.
And what happened?
What they discovered was a profound disparity in the system's error rates.
The error rates.
Yes. The COMPAS software was flagging Black defendants as high risk at nearly twice the rate of white defendants who had identical criminal histories.
Identical histories. Twice the rate.
Yeah. And furthermore, white defendants who did go on to reoffend were labeled as low risk much more often than Black defendants who went on to reoffend.
So it was wrong in opposite directions depending on race. Identical histories, wildly different algorithmic risk scores.
If I'm looking at this, I have to ask, if the algorithm isn't explicitly racist, if it's just doing complex algebra, how exactly does the poison enter the water supply?
Right.
Is it a flaw in the code itself? Like, are our math formulas fundamentally broken?
No, actually. The math formulas are executing perfectly. The code is doing exactly what we ask it to do.
Really?
Yeah. This is why Kathy O'Neill coined the term weapons of math destruction, which the text highlights. Weapons of math destruction. I love that phrase.
It's so accurate. These are opaque models that encode existing societal inequalities. They scale them up to an industrial level, and then they insulate themselves from accountability by just hiding behind proprietary secrecy.
Wow.
The algorithm isn't biased because the code is broken. The algorithm is biased because it is a perfectly accurate reflection of a flawed world.
It's a mirror. I keep coming back to this analogy. We treat AI like it's some oracle on top of a mountain, generating pure objective truth from the ether. But it's just a mirror.
That's a great way to look at it.
It only reflects the historical data we hold up to it. If the history we hold up to the mirror is unequal, the reflection is going to be unequal. But it's almost like a funhouse mirror because it takes that reflection and projects it into the future as a rigid rule.
That's a very accurate way to visualize it. And what's crucial is understanding exactly how the glass in that mirror gets warped, because it doesn't happen all at once. The text cites researchers Marabi and colleagues, who essentially mapped out the anatomy of algorithmic bias. They identified how bias infiltrates the system at different stages of the data pipeline. It's not just one single error. It's a cascade of potential traps.
So it's like a life cycle. Where does the bias actually start?
It usually begins before a single line of code is even written, with the data collection itself. This introduces what they call historical bias.
Historical bias.
Right. This occurs when your training data perfectly accurately reflects past discrimination or societal inequalities.
Which is exactly the Amazon scenario. The data was technically accurate. It accurately reflected who Amazon had hired in the past.
Exactly. The machine memorized what a successful employee looked like in, say, 2010, and naturally it reproduced that historical disparity. It couldn't imagine a future that looked different from the past.
Makes sense.
But let's say your history is perfectly equitable. You can still fail at the next step through representation bias.
Representation bias. That sounds like an issue of sample size.
It is, essentially. This happens when certain groups are simply underrepresented or absent entirely from the data sets used to train the AI.
Can you give me an example?
Sure. A classic example is facial recognition technology. If the engineers building the system scrape their training data from the internet, they are largely pulling photos of celebrities, politicians, and, stock images.
Right.
Historically, those data sets have skewed heavily toward light-skinned men.
Because that's who has historically been photographed more often in those professional contexts.
Right. So the neural network spends like 80% of its training time learning the intricate features of light-skinned male faces. When you suddenly ask it to recognize a dark-skinned female face, it performs terribly.
Because it just doesn't know how.
Exactly. Not because it is explicitly programmed to be exclusionary, but because it simply hasn't seen enough examples to learn the necessary mathematical patterns. It's like asking someone who has only ever studied French to suddenly translate a document in Swahili.
They just don't have the vocabulary. Okay, so we have the history and we have the representation. What's the next trap in the pipeline?
Measurement bias.
Measurement bias.
And this one is incredibly insidious because it deals with how we define the things we want the AI to predict.
Okay, I'm listening.
Often, the thing we actually care about is impossible to measure directly, so we use a proxy variable. We measure a shadow of the thing instead of the thing itself.
Give me an example. How do you measure a shadow?
Well, let's look at predictive policing. If a police department wants an algorithm to predict criminality so they can deploy resources efficiently, they hit a wall immediately.
Why?
Because you cannot directly measure crime. A vast amount of crime goes unreported or completely undetected. So what data do they actually have? They have data on arrests.
Right, there's a paper trail for an arrest.
But arrests are not a perfect measure of crime. They are a measure of police activity.
Oh.
Right. If police have historically patrolled certain lower-income or minority neighborhoods more heavily, perhaps due to past policies like stop and frisk, the arrest rates will be artificially higher in those areas, even if the actual baseline rate of crime is the exact same as in a wealthier neighborhood.
Wow. So the algorithm looks at the data and thinks, this zip code has tons of crime. But what it's actually seeing is this zip code has tons of police officers.
Precisely. It learns to predict arrests, not crime. But we deploy the system as if it's predicting crime, thereby baking that measurement error directly into the logic of law enforcement. We mistake the map for the territory.
That is terrifying. Okay, what happens when we get to the actual modeling, like when the AI is putting all this data together?
That's where aggregation bias comes in.
Aggregation bias.
This occurs when a one-size-fits-all model ignores vital subgroup differences. The algorithm aggregates all the data to find the most broadly applicable rule, but in doing so, it completely flattens out crucial nuances.
I'm trying to picture this. How does flattening the data cause harm?
Think about medical algorithms. A machine learning model might be trained to predict the progression of a specific respiratory disease.
Okay.
It aggregates data from 1 million patients and finds a highly accurate predictive rule for the general population. But what if the biological or environmental markers for that disease manifest completely differently in a specific minority group due to, say, different environmental exposures or genetic factors?
Oh, I see.
The general rule completely fails for them. The AI is highly accurate on average, but dangerously wrong for a specific subset.
Which naturally bleeds into the final trap, right? Evaluation bias.
Yes, exactly. Evaluation bias happens at the very end of the pipeline, when the developers are testing their finished model to see if it works before they deploy it.
Okay.
If they use performance metrics that only emphasize majority group accuracy, they might look at a dashboard and celebrate a model that is 95% accurate overall.
And I mean, 95% sounds like an A in any classroom.
It does. But they're completely ignoring the fact that the 5% error rate isn't distributed randomly. The model might be 100% accurate for the majority demographic and 0% accurate for a specific minority population. If you only look at the aggregate evaluation score, you are totally blind to the localized failure.
Okay, looking at all these structural traps, the history, the representation, the measurement, I have a pushback here.
Go for it.
And I feel like anyone listening who has ever built a basic spreadsheet is probably thinking the exact same thing right now.
Okay.
It seems like we are overcomplicating the solution. If the problem is that the AI is discriminating based on race or gender, why don't we just delete those columns from the data set? Like, if we want an AI to be blind to gender, just hide the gender data before the machine does its math. If it doesn't know you are a woman, it can't penalize you for being a woman. Problem solved, right?
It is the most intuitive, logical fix imaginable. It's actually called fairness through unawareness.
Fairness through unawareness. Catchy.
Very. And what's fascinating here is that it completely spectacularly fails in practice.
Wait, really? Why?
The text introduces a concept from researchers Barocas and Selbst that explains why. It's called redundant encoding.
Redundant encoding, meaning the information is stored multiple times in different ways.
Exactly. The idea is that protected attributes, like race, gender, or age, they do not exist in isolation. They leave deep statistical shadows throughout every other seemingly neutral column in a dataset.
Shadows.
Yes. Even if you explicitly delete the column labeled gender, the algorithm, which is literally designed to find correlations, will just exploit proxy variables that are highly correlated with gender.
I'm not sure I follow completely. If the gender column is gone, how does the math rebuild it?
Let's walk through it. Go back to a resume screening model. You delete the gender column.
Done.
You delete the name so it can't guess based on John versus Mary.
Okay, it's blind.
You think the data is clean.
Mm-hmm.
But the algorithm is analyzing hundreds of other variables. It notices that candidates who have a 2-year gap in their employment history during their late 20s or early 30s tend to have different historical success rates.
And statistically, employment gaps in that age bracket are heavily correlated with women taking time off for caregiving and maternity leave.
Exactly. So the AI starts heavily penalizing employment gaps, or it looks at the vocabulary used in the hobbies section, or it notices that candidates who attended specific liberal arts colleges have a different statistical profile.
Oh, wow.
The AI doesn't know it's looking at gender, it just pieces these shadows together. It redraws the boundaries of the protected category using a mosaic of other data points.
So the algorithm reconstructs the bias using the breadcrumbs left behind.
Yes, and Dr. Westover's text uses a really powerful example from the mortgage industry to illustrate this, citing research by Martinez and Kirchner.
What did they find?
They analyzed algorithmic lending and found that mortgage algorithms frequently end up charging Latino and African American borrowers higher interest rates, even after strictly controlling for creditworthiness.
Wait, hold on. Controlling for creditworthiness. Are you saying a minority borrower and a white borrower with the exact same FICO score, the exact same income, and the exact same debt could get different interest rates from a machine?
Yes.
How is that possible?
Because the modern algorithmic lender isn't just looking at your FICO score and your income anymore. It's processing thousands of alternative data points to build a micro profile of your risk.
Like what?
It might look at the specific zip code you live in. It might look at your purchasing habits, where you buy your groceries, or even the type of web browser or device you use to apply for the loan.
Oh, I see where this is going. And because of the history of redlining, segregation, and systemic economic disparities in this country, those seemingly neutral data points, like your zip code or your grocery store, are highly correlated with race.
Exactly. The algorithm discovers redlining all over again, entirely on its own.
That is insane.
Through redundant encoding, it learns to proxy race without ever needing a column labeled race. It just categorizes certain zip codes or digital footprints as high risk.
Okay.
And because it's a machine making the decision, the bank can point to it and say, hey, we aren't discriminating. The algorithm just doesn't like your digital footprint.
That is deeply unsettling, because understanding that a simple, technical patch like deleting a column won't work, well, it reveals that we can't just hack our way out of this. And the stakes are incredibly high, because these systems aren't experimental anymore. They are fully integrated into our most vital institutions.
The scale of deployment is just staggering. Dr. Westover's text pulls some really sobering statistics to quantify this.
Lay them on me.
Recent industry surveys show that 79% of large U.S. employers are already using algorithmic tools in at least one stage of recruitment or talent management.
79%. That is the vast majority of the corporate job market functioning behind an algorithmic gate.
It is. Think about what that means. If you are applying for a job at a Fortune 500 company today, there is a near certainty that a machine is evaluating you before a human ever even sees your name.
That is wow.
And in consumer finance, the text notes that the Fair Isaac Corporation, the creators of the FICO score, influences 90% of U.S. lending decisions. But the newer machine learning models are going far beyond traditional credit history.
Like the digital footprint stuff we just talked about.
Exactly. They are processing billions of alternative data points. Your social media activity, your smartphone usage patterns, how fast you scroll through a terms of service agreement.
Wait, really? How fast do you scroll?
Yes, your entire digital footprint is constantly being mined to determine your financial fate.
The text even mentions algorithms screening for child welfare abuse allegations, predicting which homes social workers should visit first, and algorithms prioritizing healthcare resources in hospitals. We aren't just talking about getting a slightly higher interest rate here. We are talking about life, death, and family separation.
We are. And for the organizations deploying these tools, the cascading consequences of getting it wrong are massive. Let's go back to that Workday litigation for a second. If that class action is successful, the plaintiffs are alleging violations of Title VII of the Civil Rights Act, the Age Discrimination and Employment Act, and the Americans with Disabilities Act. We are talking about potential damages in the hundreds of millions of dollars.
Plus the legal fees.
Right. Not to mention the forced exposure of highly guarded proprietary algorithms during the legal discovery process.
I would imagine the reputational damage is just as terrifying for a board of directors. The text cites a Weber-Shandwick study on consumer sentiment, right?
Yes, and the numbers in that study are a massive red flag for corporate brands. It found that 63% of consumers would actually stop purchasing products from a brand that was revealed to use discriminatory AI.
63%.
Furthermore, 71% of job seekers said they would decline an employment opportunity with a company known to use biased hiring algorithms.
So you hemorrhage your customer base and you alienate top-tier talent simultaneously. That's a death spiral.
Exactly.
Here's where it gets really interesting to me. The researchers Cowgill and Tucker call this the opportunity cost paradox. I compare this organizational efficiency paradox to a company that decides to, speed up its mailroom by throwing away any envelope that isn't white.
That's a good way to picture it.
You are moving faster, sure. You are processing the mail at lightning speed. But you are actively programming your machine to shred winning lottery tickets just because they are printed on a yellow envelope. Short-term efficiency is completely cannibalizing your long-term innovation and diversity. You are efficiently making your company worse.
That is a brilliant analogy. The algorithm makes you confidently wrong at scale. But while we analyze the corporate risk, we really cannot lose sight of the individual cost.
The people whose envelopes are being shredded.
Exactly. The text highlights the groundbreaking work by researchers Joy Buolamwini and Timnit Gibru. They published a watershed study on commercial facial recognition systems.
The Gender Shades Project, right?
Yes, gender shades. They systematically tested the facial recognition APIs from major tech companies, and they proved that intersectionality matters in AI just as much as it does in sociology. Well, the error rates for light-skinned men were incredibly low, often less than 1%. But the error rates for dark-skinned women were as high as 34.7%.
34.7% versus less than 1%. That isn't a slight margin of error. That is a canyon.
It's massive. And think about the real-world application of that technology. When facial recognition is used for building access at your workplace, or identity verification to receive your unemployment benefits, or worse, by law enforcement to identify suspects from low-quality CCTV footage.
Oh, man.
That 34% error rate actively exposes Black women to algorithmic exclusion from basic societal functions and, in the worst cases, to wrongful arrests based on a machine hallucination.
And when those wrongful arrests happen, it creates what the text calls feedback loops. I really want to dig into this because it feels like the most dystopian part of the whole research paper.
If we connect this to the bigger picture, the feedback loop is the engine that makes a sociotechnical system so incredibly difficult to dismantle. It takes a historical bias and constantly refreshes it with new, seemingly objective data.
Okay, let's look at predictive policing again to see exactly how this works mechanically. Walk me through the loop.
Sure. Step 1. A police department feeds historical arrest data into a predictive algorithm. As we discussed earlier with measurement bias, historical arrests are already skewed toward minority neighborhoods due to decades of targeted policing strategies.
Right, the algorithm sees arrests and assumes crime.
Step 2. Based on that skewed data, the algorithm generates a heat map predicting that crime will be highest in those exact same minority neighborhoods tomorrow.
Okay. Step 3. The police chief looks at the objective, mathematically generated heat map and says, we need to send our extra patrol cars to the red zone.
Exactly. Step 4. You now have a heavy concentration of police officers patrolling a specific neighborhood. What happens when you put dozens of officers on a few blocks?
They see more things.
Right. They naturally observe and make more arrests. They catch minor infractions like loitering, broken taillights, or minor drug possession that would go completely unnoticed in a neighborhood with zero police presence.
Step 5. Those new arrests are written into the database. And that new data is fed right back into the algorithm.
And the loop closes. The algorithm looks at the new arrest data and says, see? My prediction was mathematically perfect. Crime is incredibly high in this neighborhood.
Wow.
The machine updates its priors. It becomes even more confident in its bias. It recommends even more patrols for the next week. It is a literal self-fulfilling prophecy. The algorithm is mathematically laundering historical bias into future justification.
Laundering bias. That's a powerful way to say it. It's a closed loop of compounding disadvantage. When an entire demographic group experiences systematically higher rejection rates for jobs, for credit, for housing, or bail, these algorithmic systems don't just reflect structural inequality, they entrench it in cement.
They really do.
And because the decision comes from a computer interface, it looks objective. It looks like math, not prejudice. It gives decision makers plausible deniability.
Which is exactly why the regulatory landscape is finally waking up. The era of plausible deniability is rapidly coming to an end.
Thankfully.
Governments are stepping in, and they are bringing heavy legislative hammers. Dr. Westover's text outlines this shifting legal terrain. For example, in 2024, the European Union passed the Artificial Intelligence Act.
I've heard of that. It's a big deal.
It's a massive, sweeping piece of legislation. It explicitly classifies AI systems used in employment, credit scoring, and law enforcement as high risk.
And what does high risk actually mean in terms of compliance? Like, what do companies have to do?
It means you cannot just deploy these systems in the dark anymore. It mandates strict transparency, mandatory human oversight, and continuous bias monitoring. If companies violate the EU AI Act, they face fines that can reach into the tens of millions of euros, or a significant percentage of their global revenue.
That'll get a CEO's attention. And it isn't just Europe, right? The text mentions local laws here in the U.S., like New York City's Local Law 144.
Local Law 144 is fascinating because it targets employment specifically. It requires employers who use automated employment decision tools like AI resume scanners or automated video interview analysis to undergo independent third-party bias audits every single year.
Wow. Every
And
year.
they have to publicly publish a summary of those audit results.
That literally forces the black box open.
Yep.
And the U.S. Equal Employment Opportunity Commission, the EEOC, has issued explicit guidance on this too.
They have.
They've stated unequivocally that employers remain legally liable for discriminatory outcomes even if they bought the AI tool from a third-party vendor. You can't just point the finger at the software company anymore and say, well, the vendor promised us it was fair.
Exactly. If the tool you bought discriminates against your applicants, you are the one violating the Civil Rights Act. The legal shield of the machine did it is just gone.
So the critical question for every organization reading this research becomes, how do we actually fix this? If deleting the gender column doesn't work, and if we can't hide behind the vendor, what is the actual defense playbook?
That is a million-dollar question.
So what does this all mean for the engineers and the executives? The text outlines a very specific set of evidence-based interventions, and it starts before the software is ever even turned on. The first intervention is pre-deployment algorithmic impact assessments, or AIAs.
Right, AIAs. These are structured, rigorous frameworks conceptually modeled after environmental impact assessments.
Okay, like before building a factory.
Exactly. Before you build a factory, you have to prove it won't poison the local river. Before you deploy a high-stakes algorithm, you have to formally document the intended use cases, the specific data sources you were using, the model architectures, and most importantly, you have to hypothesize the potential fairness risks across different demographic groups.
But the text notes a warning from researcher Dylan Reisman and his colleagues. They argue that these impact assessments cannot just be checkboxes on a form completed by the engineering team in isolation on a Friday afternoon.
Because if it's just the engineers assessing their own work, they're going to suffer from their own blind spots. An AIA is totally useless if it's just a performative compliance exercise.
Right.
The text highlights a prime example of an AIA done right, using Microsoft's process for their Azure Face API.
Oh, this is a great story. This was their emotion recognition system, right? The software that tried to infer how a person was feeling, whether they were happy, sad, angry, or fearful, just by scanning the geometry of their facial expressions.
Exactly. Microsoft was preparing to deploy this capability widely. But as part of their pre-deployment AIA, they required cross-functional teams to engage in stakeholder mapping and disparate impact analysis. They brought in outside experts.
Good.
And during this rigorous assessment, they discovered two massive foundational flaws.
What were they?
First, on a purely technical level, they found that the system performed disproportionately poorly on non-white faces, very similar to the gender shades findings we talked about. It was misclassifying expressions based on facial structure differences that just weren't represented in the training data.
Which is bad enough on its own.
Right. But the second flaw was even more profound. Engaging with domain experts like psychologists and sociologists revealed a severe lack of scientific validity in the entire premise of the software.
Wait, hold on. Are you saying the premise of emotion recognition itself is flawed?
Yes. The experts pointed out that inferring internal emotional states solely from external facial expressions is not universally valid.
Really?
Yeah. A smile does not mean happy in every context or every culture. Sometimes people smile when they are nervous, or culturally it might be a polite response to authority. By trying to mathematically map a micro-expression to an internal state, the AI was enforcing a very narrow, culturally specific definition of emotion onto a global population.
Oh, wow. So if I'm Microsoft and I'm hearing this, I'm facing a massive sunk cost fallacy. Millions of dollars, years of engineering time have been poured into this product. The marketing materials are probably already drafted. Don't tell me they actually scrapped it.
They did. They retired the capability to infer emotional states entirely. The impact assessment did exactly what it was supposed to do. It stopped a flawed, scientifically invalid, and potentially harmful system before it could be deployed at scale and cause widespread damage.
That's incredible. It takes immense organizational maturity to kill a profitable product based on an ethical and scientific assessment.
It really does. But the text makes it clear that pre-deployment checks, even rigorous ones, aren't enough, because fairness is dynamic.
Right.
The second intervention they outline is ongoing monitoring and red team adversarial testing.
This is a crucial concept because algorithms are not static pieces of code like a word processor. They are dynamic. They constantly ingest new data and retrain on new inputs.
Exactly. A machine learning model that is perfectly balanced and fair on Monday might drift into severe bias by Friday if the data environment it operates in changes. That is why one-time audits are practically useless.
The text mentions Google's fairness, Jim. What is that exactly?
Fairness Gym is a suite of simulation tools. It allows Google's engineers to simulate how algorithmic decisions create those feedback loops we talked about, but over a simulated long-term period.
I would say fast forward time.
Essentially, yes. It lets them see the ripple effects of a minor bias compounding over time in a controlled environment before it ever hits the real world.
That's smart. And the article also mentions LinkedIn doing continuous testing of their recruiter recommendation algorithm.
Yeah, that's a great example.
They actually noticed through continuous monitoring that their job suggestions were disproportionately surfacing male candidates for certain roles. So the engineers had to continuously adjust the underlying ranking algorithms to ensure demographic parity in the search results. But I have a huge question for you about this.
Go ahead.
It sounds like a giant, exhausting game of whack-a-mole. If the data distributions are always shifting in the real world and bias is constantly creeping back into the system through new proxy variables, how do you ever actually trust the system? Aren't you just constantly chasing your own tail?
If we connect this to the bigger picture of engineering, trust isn't built on a one-time guarantee of perfection. You don't trust a commercial airliner because a mechanic looked at the engine once 5 years ago.
That's true.
You trust the plane because the cockpit is full of real-time dashboards that constantly monitor the engine pressure, the hydraulics, the altitude. If a metric drops, alarms go off immediately.
So trust is the active process of monitoring, not a static certificate of fairness.
Exactly. The text argues for real-time performance dashboards tracking demographic parity continuously. If the algorithm suddenly starts rejecting female applicants at a rate 5% higher than male applicants, a threshold is violated, an alert triggers, and the system is paused for human review. It is visible, ongoing vigilance.
And that ties into the concept of red teaming.
Yes. Red teaming is a concept borrowed from cybersecurity. In AI fairness, red teaming is where you intentionally employ independent reviewers, sometimes internal, sometimes external, to attack your own model. Yeah, you ask them to craft adversarial inputs, specifically designed to break the system's fairness constraints.
So they're actively trying to trick the AI into being biased.
Precisely. They might synthesize thousands of fake resumes that are perfectly mathematically identical in terms of qualifications, but they alter the names to strongly signal different racial or gender identities.
To see if the AI treats them differently.
Right. Or they inject subtle demographic proxies into the text. They feed these into the algorithm and measure if the output changes. You actively hunt for the bias, you try to provoke it before it can harm a real user.
Okay, so pre-deployment assessments, continuous dashboards, and red teams. Those are great tools for the data scientists and the engineers. But what about the person on the other end?
The end user.
Yeah. What about the individual whose mortgage was just denied by a machine or who was just filtered out of a job they were perfectly qualified for? Dashboards don't help them.
No, they don't.
This brings us to a concept the tech spends a lot of time on called procedural justice.
Which represents a profound shift in how we think about interacting with AI. Procedural justice theory was originally developed in the 1970s by psychologists Thibaut and Walker.
Okay.
Their research proves something fundamental about human nature. People care about more than just the final outcome of a decision. We care deeply about the fairness of the process that led to that outcome.
Even if the outcome is negative.
Even if it's negative. If a judge rules against you but allows you to speak, listens to your evidence, and explains the legal reasoning clearly, you are far more likely to accept the ruling as legitimate.
That makes total sense.
We need voice. The opportunity to present our case or correct bad data. We need transparency, understanding exactly how the decision was weighted, and we need respect.
And getting an automated generic email from a no-reply address that says, "We have reviewed your application and decided not to move forward at this time," offers absolutely zero procedural justice.
None at all. It is a psychological black box. It leaves the individual feeling powerless, unable to understand what factors influence the outcome or what they might do differently next time to improve their chances.
Right.
Now, to be fair, engineers recognize this problem, and they have tried to solve it with technical solutions called model interpretability techniques. The text mentions two prominent ones, LIME and ASHEP.
I saw those acronyms. Explain to me how LIME actually works mechanically.
So LIME stands for Local Interpretable Model Agnostic Explanations.
Say that 5 times fast.
Right. It's a way to figure out what a complex neural network is actually thinking. Imagine the AI is a black box. You feed it a loan application and it spits out denied.
Okay.
LIME works by slightly perturbing the input data. It takes your application and tweaks it hundreds of times. It lowers your income by $100, then raises it. It changes your zip code. It adjusts your credit history slightly.
Just to see what happens.
Exactly. By observing exactly when the AI changes its mind from denied to approved, Lime can map out the local boundaries of the decision.
So it generates a sort of scorecard.
Exactly. It generates what's called a feature importance score. It translates the black box into a breakdown that says, we denied your loan because variable 4, which is your debt-to-income ratio, accounted for 42% of the decision weight, and variable 7, your credit history length, accounted for 20%.
Which, I mean, that sounds transparent. But the text notes that researchers have found end users absolutely hate these technical explanations. And I completely get why. I compare receiving a Lime or Eshave score to having a bad math teacher.
How so?
You hand in your test, and the teacher just hands it back with a big red F and a note that says you failed because question 4 accounted for 42% of your grade.
Right.
It's technically true, but it's completely unhelpful. It doesn't tell you how to learn the math. End users vastly prefer what the researchers call contrastive explanations.
That is the perfect analogy. A contrastive explanation isn't a math teacher, it's a mentor.
Ooh, I like that.
A contrastive explanation doesn't just list weights and variables, it provides a counterfactual path forward. It says, look, you were denied today, but if your credit utilization had been 10% lower, or if you had 2 more years of continuous employment history, your likelihood of approval would have crossed the threshold into acceptance.
The contrastive explanation gives the user agency. It tells them the rules of the game so they can actually play it. It turns a rejection into a roadmap.
Exactly. It respects the user's dignity. And the text highlights a phenomenal real-world success story regarding this shift using the freelancing platform Upwork.
I use Upwork all the time. What did they change?
So Upwork relies heavily on algorithms to match freelancers with corporate clients. Historically, the algorithm would just present a ranked list of freelancers to a client. But freelancers who were ranked low felt completely alienated. They didn't know why they weren't getting jobs.
It's just a black box.
So Upwork redesigned the interface to provide contrastive, contextual explanations.
How does that look in practice?
Now, when the algorithm recommends a match, it explicitly tells the user why. It highlights the specific relevant skills the freelancer possesses that match the job description. It points out their past success rates on very similar projects.
Oh, that's smart.
It connects the recommendation directly to the client's stated preferences. By explaining the why behind the algorithmic match, Upwork massively increased user trust on both sides of the marketplace, and they drastically reduced complaints about perceived algorithmic bias. The transparency actually empowered the users.
But to give good, accurate explanations, whether contrastive or otherwise, you fundamentally need good data. If your underlying data set is poisoned with historical bias, your explanations are just going to be explaining the poison.
That's a huge point.
The text pivots heavily here to emphasize data stewardship. We talked about historical bias earlier. How do we actually clean the water supply?
This introduces the critical work of Timnit Gebru and her colleagues on a concept called data sheets for data sets.
Data sheets for data sets.
Historically in computer science, data sets are just treated as raw fuel. You find a data set online, you download it, and you dump it into your model. There's no context, no provenance.
It's just numbers in a spreadsheet.
Right. Gebru argues that this practice is incredibly dangerous. She proposed that every dataset used for machine learning should be accompanied by a standardized data sheet. Think of it as a nutritional label for data.
A nutritional label? What's on the label?
It meticulously documents the life cycle of the data. How was it collected? Who funded the collection? What were the specific demographic distributions of the subjects? What are the known limitations or historical biases baked into this specific collection?
Oh, that's detailed.
And most importantly, what are the explicitly recommended and prohibited use cases for this data?
So if a developer in, 2026 is trying to build a resume screening tool and they find a massive data set of hiring records from 1985, the data sheet acts as a stop sign. It says, warning, this data contains extreme historical gender bias and should absolutely not be used to train modern employment models.
Exactly. It forces intentionality. It stops the blind recycling of historical prejudice. But documentation alone isn't enough. If an organization realizes their data is skewed, say, a minority group is severely underrepresented, they can't just throw up their hands and say, well, the data is bad, nothing we can do.
Right. The text outlines active remediation techniques. Data curation. You have to actively garden the data set.
Yes. One technique is oversampling.
How does that work?
If you know that your data set only contains 5% representation of a specific demographic, but they make up 20% of the real-world population, you actively oversample that group. You duplicate their records or intentionally collect additional examples from that specific community to mathematically balance the training set.
So the algorithm has enough examples to learn their specific patterns accurately?
Exactly. The text also mentions synthetic data generation and federated learning.
Explain those to me.
Those are cutting-edge approaches. If you don't have enough data on a minority group and you can't collect more without violating their privacy, you can use generative models to create mathematically rigorous synthetic data.
Fake data.
Fake, but statistically accurate. It mimics the statistical properties of that group without containing any real personal information.
That's wild. And federated learning.
Federated learning takes a different approach. It allows a central algorithm to train across thousands of decentralized local data sets like data stored locally on individual hospital servers, without ever moving or centralizing the sensitive raw data.
Oh, so the data stays put.
Right.
Yeah.
This allows the model to learn from a vastly more diverse global population without compromising anyone's privacy.
And the text brings up IBM's AI Fairness 360 toolkit, which I think is fascinating because it's open source.
It is. It's a comprehensive library of algorithms designed specifically to detect and mitigate bias. It allows developers to apply mathematical transformations to their data before the AI even starts learning.
So fixing it on the front end?
Yes, you can actively reweigh the historical data to counteract past inequities. You mathematically penalize a bias in the training set so the machine learns a corrected version of reality rather than the flawed historical one.
Which is an incredible technical achievement. And this is the crucial pivot in Dr. Westover's research, and honestly, I think it's the most important takeaway of this entire deep dive. Ultimately, making these changes isn't just about tweaking code.
Not at all.
You can have the best data sheets, you can use IBM's Fairness 360, you can run Lime and S-Shape all day long, but if the wrong people are sitting in the room making the final decisions, the systems will still fail.
Precisely. The final section of the text moves entirely away from code and focuses on building the human infrastructure. Because AI fairness is not a technical problem to be solved, it is a human management problem.
Yes.
And it starts with vendor accountability.
Right, because let's be realistic, most companies, your average mid-sized bank, your local hospital, your city government, they aren't building their own AI from scratch. They don't have teams of machine learning PhDs on staff.
Exactly. They are buying off-the-shelf software from a vendor.
And the text is crystal clear. Organizations cannot just buy a black box algorithm, plug it into their HR department, and wash their hands of the responsibility.
The regulatory and ethical burden remains with the deployer. The text highlights guidelines issued by the U.S. General Services Administration, the GSA.
What do they say?
They have explicitly stated that government agencies must include algorithmic transparency and rigorous bias testing requirements to the actual legal text of their vendor contracts.
Meaning, if a vendor says, hey, our code is proprietary, we can't tell you how it makes decisions, the agency is required to walk away from the deal.
Exactly. You use your purchasing power to force transparency. The text highlights a brilliant example of this in the criminal justice space with a nonprofit called Uptrust.
What does Uptrust do?
They work on communication tools to help defendants navigate the justice system, and they often interface with risk assessment vendors. Uptrust has a strict policy. They force vendors to provide public, accessible documentation of their data sources, the model architectures, and most importantly, their demographic performance metrics.
They demand to see the receipts.
Right. They demand to see the error rates broken down by race and gender. If the vendor refuses to provide that transparency, Uptrust declines the partnership. They leverage their market position to force the vendors out of the black box.
That is how you change a market. You don't wait for the engineers to grow conscience, you hit them in the wallet. But internally, within your own organization, you also need the right workforce. The text cites compelling research by Rankin and colleagues showing that homogeneous technical teams constantly, predictably fail to spot bias.
It's a fundamental issue of perspective. If your entire engineering team shares the exact same demographic background, the exact same educational pedigree, and the exact same lived experience, they're going to have the exact same blind spot.
Of course they will.
They will build a system that works perfectly for people who look and live exactly like them. And they won't even realize they've excluded everyone else until the system is deployed and the lawsuits start flying.
Diversity in AI development is not just a nice corporate social responsibility talking point or a photo op for the annual report. It is a strict, Critical technical requirement for robust system design. You need cross-functional teams. You need friction in the design process.
Yes, friction is good. The text uses Salesforce as a prime example of institutionalizing this friction.
What did Salesforce do?
Salesforce established what they call the Office of Ethical and Humane Use of Technology.
But I mean, lots of companies have an ethics board that meets once a quarter, eats catered lunch, and does nothing.
That's the difference here. Salesforce staffed this office not just with PR people, but with trained ethicists, critical technologists, and policy experts. And critically, they embedded them directly into the product development lifecycle.
Oh, they put them in the trenches.
Exactly. These experts collaborate with the engineering teams from the very inception of a project, during the ideation phase, not just at the end. They aren't a rubber stamp at the finish line designed to sign off on legal compliance. They are active co-designers of the technology.
Which leads right into the final conceptual shift, participatory design. The idea that we need to fundamentally change the power dynamic of who gets to build the future. We have to co-design systems with affected communities, not just build tools for them from an ivory tower.
The text uses the example of child welfare screening algorithms to highlight this. These are incredibly high-stakes systems used to flag which families might be at risk for child abuse. Historically, these models are built by locking a bunch of data scientists in a room with a decade of Child Protective Services data.
But the data scientists have never been in the foster system. They've never been a caseworker knocking on a door at 2 a.m.
Exactly. They possess deep mathematical knowledge, but zero domain knowledge. Participatory design demands that you bring the stakeholders into the room.
That makes a lot of sense.
You involve veteran caseworkers who understand why a certain data point might be completely misleading. You involve families who have actually navigated the child welfare system and understand the realities of poverty versus neglect. You involve community advocates.
Because they possess the lived expertise that allows them to look at a proxy variable and say, wait, that doesn't mean what the math thinks it means.
Right.
But this raises an incredibly important question, one that the text really forces us to confront regarding long-term corporate governance.
What's the question that stands out to you?
Does the organization actually have the moral and structural will to do this? Because participatory design is slow. Red teaming is expensive. Retiring a flawed product like Microsoft did costs millions.
It's not easy.
No. If accountability is isolated to a single chief ethics officer, I just don't buy that it works. It becomes a performative compliance exercise. The ethics officer is just there to take the public blame when things go wrong, but they have no actual veto power to stop a profitable product launch.
That is the ultimate bottleneck. And the text addresses this by arguing for distributed accountability structures with real, undeniable teeth. True governance isn't an ethics charter on the company website.
What is it then?
True governance requires that the C-suite executives have their financial compensation directly tied to fairness outcomes.
Oh, wow. Tying the bonus to the bias audit.
Yes. When the CEO's annual bonus depends on the algorithmic impact assessment passing with strict demographic parity, suddenly the entire organizational culture shifts overnight.
Money talks.
It does. Fairness is no longer an annoying legal hurdle for the engineering team to jump over. It becomes a core strategic priority driven from the very top. You align the financial incentives with the ethical imperatives.
So what does this all mean? Synthesizing everything we've talked about today, from redundant encoding to data sheets, from Lime scores to executive compensation, it becomes overwhelmingly obvious that solving AI isn't a computer science problem at all.
It is the ultimate sociotechnical challenge. It is fundamentally a human resources challenge, a legal challenge, and a profound cultural challenge. Treating algorithmic fairness as a static technical puzzle to be solved with better math just guarantees a legal, reputational, and ethical disaster.
We've covered a tremendous amount of ground today. To summarize Dr. Westover's core thesis, AI is a sociotechnical artifact. It inherits our history. The Workday litigation, the Amazon recruiting failure, the Compass risk assessments, these case studies completely dismantle the marketing myth of algorithmic neutrality.
They absolutely do.
The calculator is reflecting our own messiness back at us.
But importantly, the text is not fatalistic. It argues forcefully that bias is neither inevitable nor irremediable. By implementing rigorous pre-deployment assessments, continuous real-time monitoring, contrastive explanations that empower users, standardized data sheets for datasets, and by demanding cross-functional participatory design, we can actually build more equitable, transparent systems.
We have the tools.
We have the tools. The real question is whether we have the institutional will to use them.
Exactly. So think about your own life right now. You are inside these data sets. Right. Your resume sitting in an applicant tracking system, your mortgage application waiting for approval, your medical records being scanned for risk factors, your credit card swipes. They are all being processed, categorized, and evaluated by these opaque algorithms right this very second.
It's happening constantly.
Understanding how they work, understanding mechanisms like redundant encoding and proxy variables, it empowers you to demand better explanations. It empowers you to demand true procedural justice when an automated system makes a decision about your life.
You have the fundamental right to ask not just what the machine decided, but how it learned to make that decision, what data it was fed, and who was in the room when that data was chosen.
Exactly. I want to leave you with one final provocative thought to mull over, drawn directly from a stark warning at the very end of Dr. Westover's text.
Right.
We spent our entire time today talking about historical bias, how algorithms learn from the flawed, human-generated data of our past. But as the industry shifts, as AI models incorporate complex reinforcement learning and generative AI, they begin introducing emergent behaviors that we cannot predict from the training data alone.
The models are beginning to create their own data. They're synthesizing new realities.
Right. Generative AI is flooding the internet with synthetic text, synthetic images, synthetic decisions. So if we are already struggling this much, requiring all these massive frameworks and red teams just to untangle the historical bias encoded in yesterday's algorithms, what happens when today's biased AI is used to generate the synthetic training data for tomorrow's AI?
That's a terrifying thought.
Are we building a digital foundation of structural inequality that will eventually become a feedback loop so complex, so dense, and so mathematically opaque that no human will ever be able to audit it? We started by talking about calculators and the comfort of precise math. But as these systems govern more of our society, maybe the real question isn't whether the math is correct. The real question is, who gets to write the equation and who gets erased by the solution? Thank you for joining us on this deep dive. Keep questioning the machines around you